Hey guys, welcome back. We're on page 21 of our factoring quadratics unit. And problem number 1, if you are looking at it and you think about numbers that multiply to make 36 is 4 times 9, and numbers that multiply to make 16 is 4 times 4, and an A, what they have in common, the greatest common factor, would be a 4. It's the biggest number that can go into both. And if you bring the 4 out, 4 times 9 would create the 36. And then 4 times a 4a would create your 16a. And this is the common factor in problem number 1. Problem number 2, you have to really look at it good. See how I have 4 y's here and there's a total of 5 of the y's here. So I can bring out 4 whole y's. Let me try to demonstrate what I'm talking about. I also see they're both negative, so you could think about it like negative 8 times 3 is 24. 1, 2, 3, 4, 5 y's multiply to make a y to the 5. And 4 y's multiply to make a y to the 4th. But what would they have in common? If we circle what they have in common, they both have a negative 8, and they both have 4 y's. And if we bring out the part they have in common, we end up with a negative 8 and y to the 4th in front. That is the greatest common factor, the GCF. What would be left would be a 3 and a y and x to the 3rd power. And over here, there's really not anything left. But when we're multiplying to get this back, if you distribute and you say negative 8 y to the 4th times 3y x cubed, well, your negative 8 times your 3 would make the negative 24. Y to the 4th times y makes y to the 5th. And then we have our x cubed. So if these multiply to get the first piece, what times negative 8y to the 4th is going to give you 8y to the 4th? A positive 1. 1 times that piece is that negative 8y to the 4th. And that is what they're talking about factoring out the greatest common factor. Now, if you look at number 5, the largest number that goes into 12 that also goes into 16, I believe, is 4. Because 4 times 3, I see y squared in both. And even though there's y to the 3rd, I know that there's a y squared in that. So that they all have in common. They don't all have an x, so we won't bring it out. You have a 4 times 3 to make that 12. You have a 4 times 4 to make that 16. So they all have a 4 that they have in common. So let's see. We can bring a 4 out. We can bring a y squared out because each piece has a y to the 2nd. And if we bring out a 4y squared, 4 times a negative 3 makes the negative 12. We already have the y squared pulled out, and now we need an x squared. So if we remultiply this, we would get this first piece. If we bring out the 4y squared, then we need a positive 3 to multiply to make this 12 in the center, and we need one more y because y squared times y makes y cubed. And the last piece, well, we already have the 4 and the y squared, so we'll need a 4 and an x. Because if we multiply 4 times 4, it gives us 16. Y squared we've got it, and then our x. So this is the factoring out the greatest common factor. Now, looking at factoring this trinomial completely, this is a review of what we did in our Friday's lesson. If you look at your C number, you have to multiply to make C, but add to make the number in the center, the B number. So 7 only has 2 numbers that multiply to make it, a 1 times a 7. And it just so happens that a 1 plus a 7 would add to be a positive 8. And then you have your x squared breaks into x times x, and this one is factored now completely. If you look at number 9, 60 is a little bit of a larger number. Let's see, 1 times 60, 2 times 30, 3 times 20, 4, let's see, how many times does 4 go into our 60? That's 15 times, 5 times 12, 6 times 10, 7 will not, 8 will not. Now we're done, okay? So which ones add to give us a 16? Let's see, well, 10 and 6. So 6 can go on one side, 10 in another. If they add together, they can give us the 16 in the middle. N squared breaks into n times n, and this one is now factored. Let's do just a couple more of these. So problem 11, if I break down the number 50, 1 times 50, 2 times 25, 3 does not, 4 does not, 5 times 10, 6, 7 doesn't, 8 doesn't, 9 doesn't. Okay, these are our factors of 50, but we're subtracting to get a 5. Subtract to get a 5. If I subtract 5 away from 10, I can get it. So we're going to use the 5 and the 10. Because the sign in the middle is a positive, we're going to give the positive sign to the 10 and a negative so that it subtracts and gives us a positive 5 left. X squared breaks into x times x, and now it is completely factored. Let's do number 13. 48 is 1 times 48, 2 times 24. 3 times 16, 4 times 12, 5 doesn't, 6 goes into 48, 6 times 8, and 7 does not. So I think we've got them all. Which ones subtract to leave you a 2? Well, it looks like our 6 and our 8. But remember, the larger number is going to take the sign of the middle, so it's going to have a minus 8 and a positive 6 in order to subtract and leave a negative 2. X squared breaks into x times x, and now this one is factored. Okay. Might as well finish the last two on this page. So 15, the factors of 15 are 1 times 15 and 3 times 5. We're subtracting to get a 2. The 3 and the 5 will subtract and give a 2. If the 2 is if the 2 is positive, the positive goes to the 5 and the negative to the 3. And then it is m squared breaks into m times m. Looking at 17, we have a 20. 20 breaks into 1 and 20, 2 and 10. 3 does not, 4 times 5, and that is all of them. And we're adding to get a 9. 4 and 5 will do it. They will add to give us a 9. M squared breaks into m times m. And this completes page 21, the odds. You guys are going to be working the evens, but let's continue on page 22. Now, 19 and 21, these are all going to do what we just saw, but number 25 kind of looks a little different. 5 does not go into all 3 pieces, so it's not a GCF. what I have tried to show you guys is the trick we can do by multiplying it to the back. Now that does give us a little bit of a large number for a moment. 56 times 5 is 280. And if I think about the number 280, I've got 1 times 280, 2 times 140. Let's see if 3 does not go into it. 4 does. 4 times 70. 5 will. And 5 times 56. Let's try 6. 6 does not. Does 7. 7 and 40. We're looking for them to subtract to make a 33. Remember, this sign tells us what to do. Subtract to get a 33. And if we subtract 40 and 7, we can do that. So I think we finally found one that would work. So we'll have our 7 on one side, 40 on another. The 40 will take the negative because it's the middle and it's the larger number. Of the middle, the middle sign goes to the larger number. P squared goes into P times P, but what did we multiply by? We multiplied by 5, so now we've got to divide by 5. Well, 5 does go into 40 8 times, so this is going to turn into P minus 8. This 7 does not divide by 5, so we squeeze the 5 to the front of the P, and then leave the 7 where it's at, and this is now the answer to number 25. 27 has an n that can be factored out, and that would leave 3n and minus a 7. So if we redistribute, n times 3n is 3n squared, n times negative 7 is negative 7n. And now this one is factored completely. Look at 29. There's no GCF in this one. And I would multiply the 3 to the back and trick the math problem just for a moment. I would write the factors of 48. And then I need to look to see what subtracts to give a 22. 2 and 24 would subtract. And because the sign in the middle is a positive, it's going to go to the 24. Negative is going to go to the 2. That way they would subtract one another. And m times m makes m squared, but we're not quite done. Remember the trick. We multiplied by 3. Now we divide by 3. Well, 24 divided by 3 makes m plus 8. 3 does not go into 2, so we'll put it in the front. So it's 3m minus 2. And that is the answer to number 29. I'd like us to skip to page 23 and do a few more off of this page. I'm going to allow you guys to stop at 43, and I want y'all to do, your assignment is going for you to complete all evens from the 2 through the 42. But I want to go through a few more and just make sure everyone is doing all right on these. Looking at this particular problem, I see this one as kind of special. Do you guys see that 9 breaks into 3 times 3 and 16 breaks into 4 times 4? This one is a little bit special. They actually refer to it as one of the special cases because it doesn't have a middle piece. It's just the two ends. One side is positive, one is negative, and it is almost a matching set. 3p times 3p does make makes 9p squared. 4 times 4 does make a negative 16 there because one was positive and one was negative. And the outer makes a negative 12p. The inner makes a positive 12p, which cancels. So that's how 37 works. 39 is similar. So watch for those special cases. They're perfect square roots. So it's 2x times 2x makes the 4x squared. It is a 3 times 3 that makes the 9. And one is positive and one is negative because the middle went away. 41, this one has a middle piece, but it's x times x, and 2 times 2 makes 4, and it also adds to make the 4 in the center. So you can write this x plus 2 to the second power. That concludes our notes to today. Good luck doing your assignment. We'll talk about any problems that you have the following day.